Picture a heart, not the squishy kind that pumps blood, but a perfect mathematical heart. This is the cardioid, a curve so elegant that has captured the imagination of mathematicians for centuries. Imagine a circle rolling around another identical circle, and trace the path of a single point on its edge. You've drawn a cardioid. Its name comes from the Greek word for heart, cardia, and its graceful equation for polar coordinate is now. You can harness the power of integration to unravel its area and trace the perimeter of this enigmatic shape. What's fascinating about this curve is that, like a chameleon, the cardioid hides in unexpected places. Look at a cup of coffee with sunlight shining on it. The reflection on the bottom forms a cardioid. It even peeks out from the mesmerizing patterns of the Mandelbrot set, a cornerstone of fractal geometry. Here is an exciting way to summon a cardioid. Start with one circle and pick a random point on it. Let's call it point P. Now, start drawing more circles, each one centered at a different point on the original circle. But always make sure they pass through point P. Interestingly, the outer edge of all those overlapping circles magically traces out a perfect cardioid. Its origins lie around 1637, when minds like Etienne Pascal, yes, father to the legendary Blaise Pascal, were captivated by its elegant form. However, back then, it belonged to a broader family of curves called the limaçon of Pascal, named for resembling a snail. The cardioid itself was a unique gem within this family. Interestingly, it took centuries for the cardioid to get its iconic heart-shaped name. That credit goes to Johann Castillon, who christened it in 1741 within the prestigious Philosophical Transactions of the Royal Society. His insight revealed its true, heart-like nature. Now get ready for another mind-bender. Picture a circle with a bunch of evenly spaced points marked around it. Now for each number, connect the dots. Draw a line from point N to point 2N. Keep doing this and bam! All of those lines will form the outline of a cardioid. Want to get even wilder? You will generate elegant geometry if you triple the point's number instead of doubling it. In fact, the cardioid is more than just theoretical. Its shape reveals how waves ripple outward from a single source. This explains why cardioid microphones are fantastic at picking up sound from the front, but are least sensitive from the back.
Here's a cardioid mic from Sennheiser. It picks up really well from the front and rejects really well from the sides and even more so from the back.